Why do animals do things that get them killed? A moth circles a porch light until it collapses. A sea turtle crawls away from the ocean and toward a hotel. A deer freezes in the middle of a road while two headlights rush toward it. From our perspective, these animals seem to be making the worst possible decision. They are doing something that could get them killed. So why hasn't evolution removed behavior like this? Because evolution does not create perfect survival machines. It creates shortcuts. Simple rules that worked often enough in the world where they evolved. And when the world changes faster than those rules can change, an instinct that once saved an animal can become a trap. For millions of years, young sea turtles emerged at night and moved toward the brightest, lowest horizon. That usually meant light reflecting from the open ocean. The rule was simple: move toward the glow. Then humans built hotels, roads, and cities beside nesting beaches. The turtle's brain did not become stupid. It followed the same ancient instruction. But the brightest horizon was now behind the beach. A survival rule pointed in the wrong direction. Scientists call situations like this ecological traps. An animal uses a familiar signal to choose food, shelter, a mate, or a route. The signal still looks trustworthy, but the choice has become dangerous. Flying insects reveal the same problem. Many stabilize themselves by keeping the brightest part of the sky above their backs. Under natural night skies, that helps them remain upright. Near a lamp, however, the light may be beside them or below them. They tilt, climb, stall, and circle. They are not choosing the lamp over survival. Their navigation system is receiving an impossible version of the signal it evolved to read. But modern technology is only part of the answer. Sometimes dangerous behavior exists because survival is not the only thing evolution rewards. Imagine a male frog calling loudly at night. Every call helps females locate him, but it may also help a hungry bat locate him. Remaining silent would be safer. It would also make him less likely to reproduce. This creates one of evolution's most important trade-offs. The same signal that attracts a mate can attract a predator. Bright feathers make a bird easier to notice. Elaborate dances require energy. Loud calls reveal an animal's position. Long journeys to breeding grounds expose animals to exhaustion, weather, and attack. So why take the risk? Because an animal that survives for years but never reproduces leaves no descendants. An animal that takes a dangerous risk and successfully reproduces may pass that tendency forward. Natural selection does not always favor the animal that lives longest. It favors traits that, on average, help genes reach the next generation. But animals do not calculate these odds. Most decisions in nature happen with incomplete information and almost no time. A grazing animal hears grass move behind it. Is it wind, a harmless bird, or a predator? If it runs every time, it wastes energy. If it waits too long once, it may die. Evolution shapes decision rules around the cost of mistakes. In many situations, a false alarm is cheaper than ignoring a real threat. That is why prey may panic at harmless sounds. But the opposite mistake also happens. An animal may freeze because remaining motionless once made it harder for a predator to detect. That defense can work against eyes searching for movement. It does not work against a car traveling at highway speed. Other animals become accustomed to humans after repeated harmless encounters. Habituation saves energy because constant fear is expensive. But when a hunter or vehicle finally appears, the animal may react too slowly. What looks like foolishness is often a decision system balancing hunger, fear, energy, and uncertainty. And sometimes death is not an accidental cost. It is built into the strategy. Pacific salmon spend enormous energy returning to their birthplace. After spawning, many die. Female octopuses may guard and clean their eggs for months while eating little, dying after the young hatch. A worker honeybee that stings a mammal may tear its body and die. These animals are not thinking, I will sacrifice myself for the future. Their behavior exists because, across generations, it helped related genes survive. A mother that protects more offspring may leave a stronger genetic legacy even if the effort shortens her life. A sterile worker may help a closely related queen produce more relatives. But here is the most disturbing part. Evolution can only respond to consequences that repeatedly affect reproduction across many generations. It cannot predict cars, glass buildings, plastic waste, electric lights, or cities built in a few decades. That is why an ancient instinct can remain powerful even when it becomes deadly. The animal is not broken. The relationship between the animal and its environment is broken. Instead of asking, why would an animal do something so stupid? Perhaps we should ask, what old problem was this behavior designed to solve? A moth circling a lamp is following a rule written under a darker sky. A turtle crawling toward a city is following a map humans have quietly redrawn. Their final mistake may belong to the animal, but the trap often belongs to us.